Okay, let's pick up on 3.3 here. So we were just talking about tangent lines. It says the image shows an angle whose rays are tangent to a circle. So remember, a tangent line is just a line that intersects with a circle at exactly one point. So it says mark the approximate points of tangency. So the points of tangency, again, are going to be just the points where the tangent lines intersect with the circle. So it looks like it's going to be about here for that tangent line, and then it's going to be about here for that tangent line. Now we want to draw the two radii that intersect these points of tangency. So we want to draw the radius here and here. And then label the measure of the central angle that is formed W. So we're going to label this W, so that's the measure of that central angle. So now the question is, what is the value of W plus Z? So we have W here, we have Z here. What's the value of W plus Z? If you want to pause and try to think about that for yourself, you can. I'll give you a hint. Think about, we aren't asked what is the value of W and what is the value of Z. If they wanted us to find the individual values, they would have asked that. But they aren't asking that. They're asking what's W plus Z. So that tells me that we should be able to figure out the measures of these two angles combined without necessarily finding the individual measures. So that's something to think about. If you want to pause and try to figure it out, you can. I'm going to go ahead and talk about it. So what did we just talk about in lesson 3.2? We talked about how we said a line is tangent to a circle if and only if it is perpendicular to the radius drawn to the point of tangency. So that if and only if also, it just means that it works the other way as well. So it tells us that if we have a radius drawn to the point of tangency, it will be perpendicular to the tangent line. So if we think about that in the context of this situation here, we have two tangent lines. It tells us that these are tangent to the circle. We have two radii drawn to the points of tangency, respectively. So these angles must be right angles, which tells us that if this is a quadrilateral and all the angles have to add up to 360, then we already have 90 and 90 accounted for. So the other two angles must add up to 180 in order for all of the angles to add to 360. So let's write this out. So let's say, so this doesn't have to be a whole proof. It just says explain your reasoning. It doesn't say prove anything. So we'll just kind of generally explain this. So we'll say the other two angles are formed by tangent lines and radii drawn to the points of tangency So they both must be right angles, meaning 90 degrees, right? Quadrilateral has 360 degrees. So 360 minus two 90-degree angles is going to be 180. So W plus Z must equal 180 degrees. All right, so the idea here is just knowing that if we have these two, we have this radius with the point of tangency, the radius to the point of tangency and the tangent line, that has to be right angle. Same thing here, has to be a right angle. Therefore, these two guys have to add up to 180 together if there's already 180 degrees accounted for in these two angles.